All right, so we're on 9.3 here today, and this is Pre-Calculus 20, McGraw-Hill Ryerson, out of this textbook right here. And we are on page 488, if you want to follow along. And we're talking about quadratic inequalities in two variables, okay? So we've been talking about inequalities all chapter. We've been talking about linear inequalities. And if you recall, linear inequalities look like this. We have a straight line, and then in two variables, that means where we have the x and the y in the inequality. And the two variables always have a solid shaded region. Now the reason is, if we have two variables, we need to have x and y coordinates, right? X and y, so 4, -2, or 2, 1, and so on. So x and y. So that means it floods this whole region, and you get a shaded region. Two variables, shaded region. One variable, okay, I'll go back to 9.1 here, or let's say, 9.2. This is a bit of a mess here, but if you remember in 9.2, if we have just one variable, see there's just x there in this inequality, it's a quadratic, then what we're looking for is we're just looking for the values of x that satisfy this inequality. So one variable is just part of the x domain, part of the number line. So where this is less than 0, we're looking for the x values that make the graph hang below the x-axis. And so that would be all x values between -1 and 4. Okay, so that's just a refresher there. Now this one here, it would be good for us to go back and just to refresh our memory on how we create this inequality. So let's say I give you this graph, just a picture, and what is the inequality represented here? Well, with a straight line, what you want to know is you want to start with the boundary, right? So this boundary right here is sort of like an equation for a line, and that's where we want to start. So what would be the equation for this boundary line? Whoops, let's get back there. So what's the equation for this boundary line? Well, I know that's going to be y equals, and I see that the y-intercept is 2 there. So I'm going to have a plus 2 over here. Remember, y equals mx plus b? All I have to find now is the m, the slope, and put it in front of the x, right? So the slope is going to go from this point, let's say, over to, oh, there's another point that's on the grid lines there. So that's going to be up 1 and over 1, 2, 3, 4. Up 1 and over 4. Rise over run. Here's the equation for that boundary line. Okay? Now, this is not an inequality yet, because we need to find out how we get these points in this blue shaded region as a part of an inequality that makes sense. So we'll start off by noticing that this is a dashed line. So it's going to be either greater than or less than, but not equal to. Okay? Because it's a dashed line. So that's the first thing. There's no equal to underneath here. Bad. If it's solid line, then there would be or equal to, right? But that line is not included in the solution region. So 0, 0. Which one of these signs make 0, 0 part of the solution? So let's say if we had 0 as y and I had 0 as x, okay, what would make sense in here? So that would be 0 is what compared to, well, 0 plus 2, or 2. 0 is less than 2. You see that? I just put in 0, 0 as a test point. And so obviously this needs to be y is less than 1/4 x plus 2. Okay? So this is the inequality that's represented here by this diagram. Okay? Now that's going to serve us well, because what we're talking about here in this section, the final section of the textbook actually, it's exciting, isn't it, is quadratic inequalities. So think about this. This is a linear. Now a quadratic inequality looks like this right here. Okay? And all it is a parabola with either the sort of outside of the parabola shaded or the inside shaded. In this case, this is the outside is shaded. And this is what this inequality looks like. Now, again, two variables, we have a shaded region. Do we have two variables here? Yeah, we have x and we have y, both represented in this inequality. Notice that this is a not or equal to, so the boundary line, which is this equation here, so this is the boundary line, right? This right here, if we were to graph that, that's the boundary. because there's no equal to, the boundary has to be a dashed line, okay? Now, how do I know if it's outside, like this, or if it's maybe the inside? Because the solution region could be in here. Again, use a test point, right? So 0, 0 is always the best one. For me, it's always the easiest one because you just get rid of terms right away if you plug 0, 0 in. So if 0, 0 is not on the line or on the parabola or on the boundary, good idea to use 0, 0, right? So let's test 0, 0 and to see if this is correct. Of course, we kind of know it is correct, but let's just test 0, 0. So 0 is less than 0 minus 2 times 0 minus 3, or 0 is less than negative 3. Well, this doesn't work, right? So that means that 0, 0 is not in the solution region. So if this was you trying to shade either the inside or the outside, you'd say, oh, 0, 0 is not part of the solution region, so I have to shade wherever 0, 0 is not, on the outside here, okay? And that's 9.3. That's the only difference. So we've done inequalities with one variable, where we just identify the part of the domain, the x-axis, right? That's associated with positive or negative. And we've done two variables where we shade a region either above or below a line. Now it's two variables shading a region that's either inside, quotes, or outside of the variable, or of the parabola, okay? All right, so let's do one here where we have to generate a graph. And let's start from scratch, generate a graph. Let's examine how we would do this. And then we'd have to test if this point is in the solution of the inequality. So let's start from scratch here. This is example 1. It's in your textbook. If you're following along the textbook, and if you want to follow along, this is on page 490. So graph this. Okay, well, what we have to understand is that this, I can graph this actual equation, and that would form my boundary. Okay, so that's always the first step. Graph the equation. Now this boundary is going to be dashed because there's no or equal to here, right? But let's figure out what this is. Now you can get on your graphing calculator, but let's practice without because you need to understand kind of how to graph without as well. So let's do that. You should recall that this is vertex graphing form. So the vertex here, right? Let me change colors for you. The vertex is the point positive 3, always the opposite sign of what's in here. If that's positive, then this has to be changed. So positive 3 and the same sign out here, positive 1. So I've already got this marked here. I've drawn a coordinate plane for you. So I'm going to go over 1, 2, 3, and up 1 right here. That's my vertex, okay? 3, 1. Now, what do? Well, we know that it opens downward because there's a negative sign, and I know that A is 2. So remember, if A was 1, from the vertex, we would go over 1, down 1. That's how we know that it opens normally. Over 1, down 1. Or over 1, up 1 if it's opening up. But because A is a 2, the first easy thing you can do to sketch this graph is go over 1 unit and down 2 units. See that? Over 1 unit and down 2 because that's what A is. And that's the first easiest thing you can do to start to sketch. So I would do that. The other thing I would do is find out what the y-intercept is. So we know it's going to be down here somewhere, right, in this region maybe. So let's figure out what that is, and that happens when when x equals 0. So what is y when x equals 0? Well, what is this? Okay, so this is going to be negative 2 times negative 3 squared is positive 9 plus 1. So y is negative 18 plus 1, or the x-intercept is negative, 17. So it's going to be way down here, negative 17. We don't even have room for that on a graph. But suffice it to say, the parabola is going to look something like this, okay? It's going to go down, hit this point, and it's going to go way down here somewhere. And it's symmetrical, so it's going to do the same thing on this side, okay? This is good enough for a sketch right now, just a sketch. Okay, so that's a good sketch. We've got a few important points there. This is great. Now, B says, determine if the point 2, negative 4 is a solution to the inequality. So 2, negative 4, well, now that you've graphed this, you can actually look to see where 2, negative 4 is and see if that's part of the solution region. So whatever you want to do first, I would place this 2, negative 4, 1, 2, and then negative 4, 1, 2, 3, 4. So it's obviously inside this parabola. Now I have to figure out if that point, or if the inside region here is the solution set to this inequality. And you know what? really easy. You can just go ahead and test the point. So let's do that over here. So y is -4. And I'm just going to see if this point fits, okay, or works here. So it's going to be 2 minus 3 squared plus 1 on the right side. So -4, is that less than what's on this side? Well, let's see, 2, -4. So 2 minus 3 is -1, squared is 1, so it's -2 plus 1. So -4, is it less than -1? It is, yeah. So this is true. So that means that this point is inside the solution region, which would be looking like this. Okay? So there you've got your answer. We've graphed it and determined if the point is a solution. Yes, it is, because here it is right here. And we know that the solution region is sort of inside this parabola. Okay? So that's example 1. And we're going to move to example 3 here now. One more example before we're done this lesson. Again, a brief lesson. We're going to get to the summary here right after this example. So let's take a look at example 3 now, where this is a word problem, and a lot of times we struggle with word problems to put things together. So let me just work through one with you. So you can use a parabolic reflector to focus sound. So here's a guy here at the side of looks like a football game or a soccer game or something, and he's pointing the parabolic reflector at the action because he wants to collect all of the sound. So if you've taken physical science, you know that there is a focus to parabolic reflectors, and everything that comes into that parabolic reflector will reflect through the focus. All of these sound waves bounce back through one. And here's the microphone right here. So I don't know if you can see that the microphone is somewhere around there, right at the focal point of this parabola. Okay, so a parabolic microphone has a parabolic reflector. It describes it here. Rene, a journalist, is using a parabolic microphone. He covers the Francophone Summer Festival, Vancouver. Describe the region that Rene can cover with his microphone if the reflector has a width of 50 centimeters and a maximum depth of 15. Okay, so he's holding it sideways. What we're going to do is we're going to try and fit this onto a coordinate plane. Okay, so let's make the vertex of the dish right here at 0, 0. And let's make that dish sort of a parabola that opens upward. Now I'm going to sketch this parabola out with a vertex at 0, 0. It's going to look something like this. And you can pick anywhere on the plane. I would say that this is probably the easiest because our equation is going to be nice and easy, and it's going to be easy to draw here and work with. So some details. A maximum depth of 15 centimeters. So that means from the edges here down to the maximum depth, which would be at the vertex of this parabola, is 15. So guess what? This is going to be 15 on the y-axis, a depth of 15. Got it? The reflector itself, this parabolic reflector itself, the dish has a width of 50 centimeters. So guess what? If this is 50, then I know what this length is. That's 25. And so is this, 25, right? And so my point here is going to be 25, 15, 25, 15. This is going to be negative 25, 15, right? So now we're taking this situation here and we're putting it onto a coordinate plane so we can actually get some points to work with, okay? All right, so the question says, describe the region Rene can cover. Well, this parabolic dish is only this wide, so I guess we have a bit of a domain here, right? So it can cover a certain width of sound, so that's going to be important. So I guess the domain, if we're going to describe this area, is going to have to be between negative 25, okay, and it'll, I guess, include that. We can include that. Okay, so let's say x is our horizontal axis here, between negative 25 and 25. Okay, this is going to be in centimeters, right? So that's our domain. We can't go further than that because the dish is not wider than that. All right, and so it would probably be a good idea then to focus on how we can say that the sound that we can hear is in here. So this would be like inside the parabola, wouldn't it? Inside the parabola. Okay? So we want to find some kind of inequality here that will match this. Okay. Now, algebraically, we can come up with an inequality here. Okay, so this is sort of the visual right here. This is the visual graphical representation. What does the actual equation look like? Well, we have a vertex of 0, 0, so we've got something like this, vertex form, right? Which really is y equals ax squared, because the zeros there, don't really count for anything. So if I plugged in 1 point and the vertex, which is 0, 0, I could find out what a is. And we would do that by going, hey, let's plug in one of these points. So 15 equals a times 25 squared. And so a is going to be equal to 15 over, what's that, 625, which is going to be simplified to 3 over 125. Okay, all right, so that's right. So, 5, yeah. So there's our a value. So our equation of the boundary line is going to be 3 over 125 times x squared. That's the equation. Now the inequality has to include these points. So is it going to be greater than or equal to? And I guess you could just plug in a point, and I'm going to plug in 0, 15, because I know that that's inside this region. So 15 is the y, and I've got 0 squared here, so that's going to make this easy. 15 is what compared to 0? Well, it's greater than. So the inequality, now should we include the points on the parabola? That's a good question. I don't know. Probably just the sound is not made in the parabola, right? In the dish, I should say. So let's just go greater than. So y is greater than 3 over 125 x squared. So that looks like it's going to be your inequality there for this, okay? Now I see in the textbook they do equals or equals to, so I'm okay with that too, but I would say the sound would be, I guess the parabola could, the dish could vibrate, right? So you could have sound generating from the dish, I'm fine with that. So if you do equals, I'm okay with that too. Really in this question it goes either way. All right, so that wraps up our lesson for today. Please look through the key ideas right here. Take a moment to read through those. And your assignment is here below. So 9.3, this is your assignment. 1AC, 2AC, 3AC, 4A, 5A, 6A, 8, and 9. So I'll just show you that in the textbook here.